On behalf of Space Education and Research Foundation, and on my personal behalf, it is my pleasure to welcome Professor Arup Dasgupta, the speaker for this webinar on satellite communication, and all the participants from different countries. Today is the third talk of this webinar series, and the module 3 that will be delivered today is on communication satellite services. Before I hand over this mic to Professor Arup Dasgupta, I will introduce him briefly to you. Professor Arup Dasgupta had a very excellent academic and professional career. He did his master's in engineering, in electrical communication engineering from Indian Institute of Science, Bangalore in 1970. And then he joined Space Application Center. At present, he is managing editor of Geospatial World magazine, and he was also adjunct faculty in two renowned institutes in Ahmedabad, DAIICT and SET. He has a 48 years of experience in satellite communication, remote sensing, and GIS technology. He retired from Space Application Center in 2005 as the Deputy Director of SATCOM and IT Applications area. After that, he served for 4 years as a distinguished professor at BISAC from 2005 to 2009, and from 2009 to 2014 he served as independent director in ScanPoint Geomatics. He has made very significant contribution, and for his contribution he received excellence awards. He received Excellence Award for 2005 from Indian Society of Remote Sensing, and for 2016 from Indian Society of Geomatics. He is also a recipient of Geospatial Lifetime Achievement Award in Geospatial Technologies for 2009 and Astronautical Society of India's Award for Space Science and Application for 2000. He is a senior member of IEEE, Fellow of IETE, Fellow of ISG, Life Member of INCA, and ISRS. His current interests are space policy, geoconvergence of space and information technology for sustainable development of the planet Earth. With these few words, I now invite Professor Dasgupta, and I leave this room.
Thank you, Professor Watts. Very nice introduction, and a very warm welcome to all of you. Just 1 second, please. I just have to change my location for a minute. Yeah, okay. So I'm a little bit more comfortable now. So I spilled a glass of water. Okay. So warm welcome again to the participants. And today I'll be talking satellite services. Before I begin this, I also should mention that in yesterday's talk, I found that two of the slides had been garbled, and I have corrected them and sent them over to Professor Vats if he can include it in the slide upload, if not the video recording. Also, I was suggested that talk a little bit about our experience in the site DRS, the Satellite Instruction Television Experiment Direct Reception System, which we conducted in 1975. So I've added one slide on that also. So at a later date, you may like to look at those. Okay, so let's get on with our topic today. And our topic today is going to be communication satellite services. Now, some time ago, I think I got a question that is satellites only used for is only used for is satellite only used for broadcasting? And the answer is no. The satellite is not used only for broadcasting. The satellite is used for many applications. So we are going to look at those applications, and these applications come under several categories. First is what is called the fixed satellite service. This is the oldest category. Then came the mobile satellite service. Then came the maritime communication satellite services. Then satellites for handheld mobile communication. Then of course broadcast satellite services, and then meteorological, internet, and other kind of services. And we shall see how these services have slowly evolved over time. Okay, so fixed satellite service. Uh, uh, what are they? So in the under fixed satellite service, mainly it is communications related to voice and data, but many other things are also added onto it. We will see. Then we have the broadcast satellite service. In under that we have, for example, the direct audio and radio service. That's called the DARS. Then you have the direct to home TV, which all of you are very familiar with. The audio radio service, in fact, there was a very popular system which unfortunately failed, but you could use that and receive the radio signals, radio programs from various parts of the world. Then mobile satellite services are really divided into three. First is the aero mobile. For example, you nowadays keep hearing news that now you can use your mobile phone on the aircraft. How is that possible? And that's really the aero mobile. Then you have the land mobile, which is fairly common. You might have heard of that. Suraya basically allows you to use your mobile phone with an attachment on top to be able to directly call anybody else in the world who has a similar uh, uh, attachment available. Then you have the maritime mobile, and that again is very important because maritime services, particularly when distresses happen and things like that, this is extremely important to have this kind of service. Then you have the special services, and the special services, of course, meteorological data services. This is something that many people don't know about, but there's a lot of meteorological data which is transferred over satellites. These are not only the satellite pictures, but also data from various automatic weather stations. Then you have the experimental and amateur use. You might have ham sats and things like that, where people make satellites which are meant only for use by ham radio enthusiasts. Then of course you have the internet services, and on this I'll be spending a lot of time because internet services is really something that is revolutionizing satellite communications. So there are certain frequency bands which are allotted according to the various services by the International Telecommunication Union. And these, as you can see over here, extend from the L band right up to the band. The L band, which is basically 1.5 to 1.7 gigahertz, is essentially used for mobile satellite services. The S band, which is from 2 to 2.7 gigahertz, these are essentially mobile satellite service, but also digital audio radio services. Then the C band, which is 3.4 to 7.1 gigahertz. This is for the fixed satellite service. As I told you, this was the first set satellite services which were used, and you can see the band, it was in C band. Then you have the X band. And the X band actually 7.25 to 8.4 gigahertz is mainly for military use and for satellite imagery use. In fact, in India, all our satellite imaging systems are using this band. Then you have the Ku band, which is quite familiar to all of you, at 10.7 to 14.5 gigahertz. Again, interestingly, satellite services, but also very much used for broadcast satellite services. Then you have the Ka band, and that is 17.7 to 21.2 gigahertz and 27.5 to 27.5 to I think about 30 gigahertz. This is again used for fixed satellite broadband and inter-satellite links. So we will cover each of these in a detail. So let's look at the who are the fixed satellite service operators first. There are 4 global fixed satellite service operators. Intelsat is the oldest one. As I mentioned to you, it was Eutelsat is corresponding European consortium. Then you have an American consortium called SES and an Italian group called the Telesat. C and Ku bands operators are, in addition, in 30 regional or national satellite operators are there. Out of these 30, 15 are Asian, 10 are Europe and Middle East, Latin America, and 3 are North America. So you see, fixed satellite services are both international as well as regional. In fact, our INSAT system is a typical example of a regional fixed satellite service. Then in the Ka band, you have multiple new operators, and these are being driven by consumer satellite broadband in the US and Europe. Mainly because the Ka band is susceptible to heavy rain and rain rate, so they haven't really made any impact so far in the Asian region, but we are getting there. And the companies who are involved in that are Hughes, Wild Blue, Viasat, Global Express, which is proposing a global Ka band system. Inmarsat essentially is a marine satellite service provider, but they are now getting into the what they call earlier they called it the G-band, now they are calling it the Global Express, which will basically provide you satellite broadband system all over the world in a Ka band. Commercial X-band operators are mainly for military support. US, there is something called X-Star, and in UK something called Paradigm. So again, going back a little into the history, you see the Intelsat Nano 6, a typical FSS satellite. Still a fairly old one. The new ones are much more powerful, but I just use it as an example. C-band up to 72 transponders, which is this is taken in equivalent 36 megahertz unit. Normally, in a fixed satellite service, each quote-unquote transponder has a bandwidth of 36 megahertz. Now, this doesn't mean that it's a physical transponder which has only 36 megahertz. The transponder itself may be very much wideband, but it is the bands are split into 36 megahertz units, and that's how it you get a number of 72 in 72 transponders. Okay. Each is 36 megahertz, is counted in 36 megahertz units, right? And these are covered for 4 zones. So we have zonal beams, right? And you can see over here, this is the global beam. You can see here, 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 and here, right? And then you have the Ku band, that 22 again. This is counted in equivalent of 36 megahertz units, and then you have the downlink EIRP. Now look at the kind of EIRPs you are talking about. The global beam is roughly around 31 to 35.9 dB watts. The heavy beam, which is half beam, is 36 to 41. Zonal beams are 36 to 44 dB watts. The Ku band is up to 54 dB watts. So it's a very, very powerful satellite. And this is in 2002. So today is much more. Again, comparing to a regional system, this is our INSAT 3C, which was also launched around the same time, 2002. And again, here you see 24 transponders dBW in the C band, 6 transponders at 37 dBW in the extended C band. Okay, one of the things that the ITU had done is looking at the evolution of the fixed satellite services. They had opened up certain amount of frequencies in the lower part of the C band, right? And therefore, this is called the extended C band, and many countries like India made very great use of it. So you had these 6 transponders in that 37 dB watt in the extended C band. Then you had 2 transponders at 42 dB watt in the S band. Again, you see the S band again is used for mobile satellite services, and I will show you some examples of how it was used in India. But the important point to note is 42 dB watts. So that means you could use very small devices. Then you have one transponder at 37 dB watt in what we call as a C cross S mobile. I'll explain this to you when I come to the relevant part. And you have this particular satellite had 10 years of lifetime, and now these satellites are all having 15 years or more. So here is again typical fixed satellite services, and there you can see, for example, video services in terms of video distribution for network and cable head ends and DTH, right? This is one. Then video contribution in terms of satellite news gathering. You might have seen in many places you have a little van with the antenna on top, and whenever there is some event somewhere or some accident or something, these people go there, and then the cameramen fan out, and the signals are directly transmitted via this small antenna, and then that satellite retransmits it back to the broadcasting station, and the broadcasting station puts it on your TV, and you are able to see live many of the events that are happening. So video contribution in terms of satellite news gathering is one of the important applications of the fixed satellite service. Then business TV, mainly dealing with video conferencing and things like that. And then video on demand, that is where you can ask for a particular program to be shown or movie to be shown. For example, in many of the DTH service providers, they can actually give you a list of movies which you can order on demand, anyone of that choice, and it is played back for you, right? So this video on demand is there. Other important thing is, of course, video conferencing, which is very widely used. Okay, so these are some of the video kind of services. Then there are the telecommunication services, which really started much before the others. So these are private networks or VSAT networks. Okay, what is a VSAT? A VSAT is a very small aperture terminal. Okay, and typical VSAT terminals may be around 1 meter to 1.2 meters in size. They can be mounted on top of a van, and they are very easy to deploy. And as I mentioned to you, these terminals can then drive down to a event location, and from there live video and audio signals can be transferred. Uh, so most of these are, for example, from the news channels, but also many of them are very private networks, big business houses which have offices all over the country, I mean all over the world. If it's an MNC, then they have these private VSAT networks which is used only for their internal communications. Data broadcasting is also again an important telecom service. As I mentioned to you, for example, the meteorological transmission, a lot of other even military data transmission. Rural telephony again is a very important issue where in countries the rural coverage of the telephone is poor, so there rural telephony using VSAT is also being used. And most interestingly, even in cellular backhaul it is used. For example, if you have a cellular in a rural area, if you have a cellular uh, uh, in a rural area, if you can establish a cellular network. Now, how do I connect it to the main cellular network? I can do that through satellite. In fact, a similar experiment has been done by IIT Madras, and it has been quite successful. Then you have many other services like meteorology I mentioned. One is the distribution of the satellite images, the distribution of satellite the data collection platforms, from automated data collection platforms in remote areas. Even you can get it from marine areas where marine buoys are fitted with this particular technology, and whatever readings are being taken by these buoys as they move around in the sea can be picked up and transmitted back to a central station. So you can not only get the details about the land-based stations, but you can also get details of the marine stations. Then search and rescue is a very important part where if a aircraft or ship or an individual has got into a problem, search and rescue operations are part of the fixed satellite service. We'll look at it how. And then of course the internet is something that is being coming up very fast. So again, let's look at a regional application, and this is basically from the INSAT services. We have telecommunications, 5600 two-way speech circuits, right? And this is mind you 1981, so it's pretty old. So, but still, to give you an idea, 5600 two-way speech circuits, right? That means at any given time, using the satellite, 5600 people can be talking to another 5600 people. Then you have 250 earth stations. So these are various kinds of earth stations, receive only earth stations, talkback earth stations, and so forth. So all these are included, and then you have 10,000 VSATs possible. Right? Television, 22 TV channels. In India today, all our TV channels are basically connected to INSAT through the fixed satellite services, and all the programs from any station to your TV. So there are 22 TV channels, then there are 1154 terrestrial transmitters, and these are fed by what is called TVRO terminals, that is TV receive only. So what happens is that in India, people still use a radio, and interconnect and making radio available, different regional radio stations available to people all over the country. What was done was that many of these radio stations, they connected through these TV receive only terminals to the terrestrial transmitters. So what would happen is, suppose there is a very famous music festival happening. For example, in India, down south there is something very famous called the Tyagaraja music festival, right? So now there are a lot of people living outside of South India who are basically fans of this. So the idea was that you could then directly rebroadcast it through the satellite and then through the terrestrial network, and you get a very clear and noise-free reception of the radio signal. I talked to you about darts. This is one application of darts. Then radio networking, that of course again 224 stations which are using C crosses transponders in SPC mode. I will not go into the details of that. So here again just we have put schematically some of the applications. So you have VSATs, you have speed circuits, you have wireless telephony, you have TV broadcasting, other applications. This is the mobile satellite phone, a mobile receiving, transmitting terminal, DTH of course, and search and rescue. We'll go into these a little later. So here is one typical use of a fixed satellite service, and this is called the Training and Development Communication Channel, which was developed by ISRO using SAT. So here what is done is that you have the Earth station here, which has a studio and which has a teaching end. That's basically teaching material are assembled, and then there are teachers who will broadcast the lessons from the studio to the Earth station, then received by all these different receive terminals, right? And they are direct receive terminals. Their sizes are of order of, again, as I said, about 3 to 4 meters. And then you can have some in which they will only receive the lessons, but you cannot talk back. Then you have some in which you can actually talk back. That means students who are looking at the lessons, they are able to ask questions, and these questions are directly fed back through the satellite to the studio. In some cases where this facility is not there, they can actually ask questions either over the phone or by email or by sending a fax, and all this also gets fed back to teacher. So this becomes an interactive teaching channel. So this is the most primitive one. This is the most advanced one, where you use only the satellite, and this is a kind of via media where you use the satellite to receive the signal, and you use other communication links to have the interaction, the feedback. Here is again another very interesting network which has been set up and it's currently operational. It's a telemedicine network. Here again what is done is that you have a hub station, okay, which is located with a major super speciality hospital. So in this case you can see Narayan Hridayalaya, Bangalore. This is a super speciality hospital which deals mainly with the heart issues, right? And then you have one more such hub which is located in Kolkata, and this is called the Rabindranath Tagore International Institute of Cardiac Sciences. And these two are again interconnected on the ground through ISDN, and you have specialists sitting at both sides. Now here are at the other end, you have, for example, the Chamarajanagar District Hospital in a place called Mysore. You have the SBYM Hospital in a place called Kanchanhalli. You have another similar setup in a place called in Tripura Sundari Hospital. And now what happens is the patients, they come to these locations. Various parameters, medical parameters are measured, and these are then transmitted to the super specialty hospitals, where the specialists will look through these. Also, they are able to remotely look at the person, his appearance and so forth, and then they are able to give advice to the local doctors here as to what course of treatment is followed. So in this way, what the telemedicine network has done is basically it has made the specialist available to remote areas all over the India. And in this, doing this, it has immensely enhanced the medical services. And this is again a major application of the fixed satellite services. Then, of course, this is a very interesting application which we developed with the NS Swaminathan Research Foundation. The NS Swaminathan Research Foundation was supporting the villages in the coastal areas with information on things like socio-economic issues relating to the village, and this is down south in Pondicherry. So what was done was that a small terminal was set up, okay, and a place called Villanur, and they had a transmission. They had a terrestrial transmitter available, and the villages like this is called Virampattinam. This is the typical scene in the village where they have a reception center, and this, of course, is the research foundation. So the research foundation would receive the signal, get the information, and then retransmit it through satellite, and then with the corrected information, it will then broadcast it to these villages. So this again is a fixed satellite service, which an experiment was tried out, and this has grown into something much bigger. Now here is again another application. This is again in terms of education, and this is one of the first multi-beam satellites that we have used. We will talk about multi-beam satellites later on. This was EduSat, or parallelly known as popularly known as GSAT-3, and it had 5 spot beams in the Ku band with a very high ERP, 55 dB watts, and a G by T of 7 dB per degree Kelvin. Right? So this enables you to use very small terminals. So there was a national beam in the Ku band, again 50 dB watts with a G by T of 3 dB per degree Kelvin. So this, as you see, is the national beam, and then we had national beam in the extended C band, which carried 6 channels, and these were 38 dB watt, and these required a little larger size antenna. These were mainly provided for continuity of service because already we had quite a lot of setups using the extended C band, and we didn't want to lose out on that. So here are some of the possibilities of the EduSat. So again, almost everything can be done with EduSat: radio broadcasting, TV broadcasting. You could use nighttime to load programs at the receiving end and then play it back without the satellite in the daytime. Online education is possible. Use the telephone as a return link if not possible. Use the internet as a possible return link, and so forth. So all these kind of things are available, and what was done was essentially this is how it operated. Okay, so first you had a hub station, and the hub station was located in the state capital. Right? So the state capital would then collect the programs from various places and then transmit it. EduSat would then retransmit it in extended C band to existing networks which are there in existing C band, but they would also transmit in Ku band to the new set. Now, for example, if you have a large engineering college or university, then with a 1.8 meter antenna, you could have a a connectivity 2-way, right? Similarly, higher secondary schools and colleges, here of course the antenna is used would be 1.2 meters. Why is the difference? Is because here you will have many more students, here you will have less students, and here you will have even lesser students, right? So the load of talkback is going to be lesser, and in some cases, in fact, there may not be any talkback at all, right? So therefore, in schools, for example, there is only receive-only terminals which receive the programs, and as I said, they can be loaded in the night time, and then in the daytime the teacher can come and replay it. In uh, higher secondary schools and colleges, there may be a interactive requirement for which either you can use the wireless in local loop or the telephone or the system itself. All three options are there. And as I said, in colleges again, in colleges in fact you can also have a video feedback. That means the can be seen. If you want to show something, that can be seen, right? And therefore you require a more powerful antenna system. So that's why you have 1.8 meter here. You have 1.2 meter here because it's only talkback, and you have 0.75 meter here because it's only a receive only. Okay, so that is what all the fixed satellite services are all about. So then let's talk about the mobile satellite services. Here again, you see in the global scenario, there are three of them: Inmarsat, Iridium, and Global Star. Then you have regional ones. These are mainly in the American continent: Light Squared, Terrestar, and DBSD. And in the regional, you have things like Raya, which is basically dealing with Africa and the Middle East and Asia. And then you have ACES, which is mainly dealing with Asia. So these are the various mobile operators. And again, the kind of services that they will provide: voice and data services anytime, anywhere. This is the beauty of it. Anytime is okay, but anywhere. That's where the mobile part of it comes. Then this is also very critical to consumer industry and first responders. Voice and data connectivity. It is ubiquitous and resilient mobile connectivity. What do I mean by ubiquitous? It means that you don't have to, it is inbuilt. You don't have to do any special effort to connect to these services. They are inbuilt in your system. So, you can have a receiver, and that receiver you can keep anywhere, and you can just open the receiver and connect to anybody else anywhere in the world. Then you have the dual mode handsets, which are, for, as I mentioned, you can have your normal cell phone, which you use your normal GSM, and then you can attach this attachment, and then you can use it as a cellular satellite mobile. So these are called the dual mode handsets. And then of course you can get broadband speeds. Then you have remote data, telemetry monitoring infrastructure. For example, if you have utilities like oil, gas, water pipelines, electrical distribution, and so forth, and these need to be monitored. I do not know if you have heard of something called the SCADA, that is the Supervisory Control and Data Analysis, SCADA. And SCADA is very much in use by all these utilities to monitor the network of their services, right? And the important thing is that where there are critical assets, like for example pumping stations or for example transformers, so here you can actually have a remote terminal which can directly transmit the status of the assets through the satellite to the central control authority. So this is one particular use of remote data telemetry. Similarly, it can be used on mobile these things like uh, uh, that give you the location and status of the mobile object. Then in the maritime and aeronautical communications, one of the most important thing is of course the it is a lifeline for the ships and planes and trucks on the railroads. And then you have the emergency communications, that is, as I mentioned, if some mishap has happened and things like that. And then sometimes it is also used for tracking dangerous shipments, like for example nuclear fuel and so forth, rocket engines and so forth, which are sent out by sea or by air. These can be tracked using satellite services. So here is a typical example of the Inmarsat marine mobile. Here you see a schematic of one of the first satellites, and you can see this huge antenna which is there. The user, and this works in L band, 49 dB watt, and the feeder link is in C band at 30 dB watt, and the coverage is global for C band and global and. So here you can see how the coverage is there, and it covers most of the sea routes. Okay, not so much the land, the sea routes, but it's used on land as well. And this is a kind of typical Inmarsat telephone. Okay, where you have to just lift up the. This is actually the antenna, so you can just lift it up, point it towards the satellite, and then start using it. Here is another mobile application. This one is called the ACS. It's a geomobile system. Again, you have two huge antennas. They are 12-meter antennas in L band, 140 spot beams. So if you can have the patience to count them, you can see that they cover most of India, Pakistan, China, Tibet, and totally the Southeast Asian region, including Indonesia and Philippines and so forth. Right? And this is a typical handheld receiver. This, as you can see, is so here you can see typically the kind of receiver, and this is a normal GSM mobile phone, and on top you see this little arrangement. This is basically what enables the mobile phone to then directly talk to the ACS Geo Mobile. And so technically speaking, if you own this phone, you can then from wherever you are, like I'm somewhere here, to anybody else, say to my friend, let's say in Indonesia, right? So I can do that. So you have a 3-meter C-band antenna to communicate with the gateways, right? They need gateways to be able to switch the callers from one beam to another. So you can do handset to handset calls. You can do handset to public switch telephone network. That means your standard telephone, or you can do handset to any other GSM. That's also possible. And the GSM and PSTN will be handled through the gateway stations. Handset to handset is direct. Okay. Now this is a very interesting system. Unfortunately, it has failed. This is called Iridium. Again, it's a low Earth orbit mobile system. It had 66 satellites in orbit at 780 kilometers height, and it had 48 spot beams. Now, how did it work? So you can see the example here. So you have the Iridium satellites, right? There are 3 of them. They are talking to each other on the Ka band, but on the ground they are talking in the L band as well as Ka band. In the Ka band, they are talking to gateways, and the gateways are then connecting through terrestrial networks. And in the L band, they are directly talking to the EDM telephones which are available, and similarly so many other devices. How does this work is very interesting. If you think how your GSM phone works, you have all these stations, the towers, right, all around your place, and wherever you are having your, whenever you switch on your handset, then the handset gets connected to one of the towers which is nearest to you. So then, if somebody is calling you, the system finds out where you are and then. Alternatively, let's say I'm sitting in a car and talking to somebody. As I keep passing from tower to tower, the tower hands me over to the next tower, right? And so therefore, I do not get any break in my communications. At least that's the way it's supposed to be. But nowadays, call drops are supposed to also happen. Okay. Now, in case of Iridium, what they did was they put the towers in the sky. So each of these Iridium satellites, you can think of them as the towers. And but the towers are moving because they are orbiting the satellite, orbiting the Earth, right? So, but the principle is the same. That is, as one satellite moves away, it hands your call over to the next satellite that is coming. So, for example, let's see, there is this lady over here who is talking through the terrestrial network through the gateway with this satellite, but this satellite is soon going to disappear. So there is a carband link which will allow the satellite to tell this satellite, hey look, I have got this connection coming up, you may please take over at this time. So by the time this fellow goes out, this fellow comes here, the connection is maintained and therefore this lady can go on talking. So this is the way the Iridium was supposed to work. It's a brilliant idea. Unfortunately, their business plan not so good, and so the system has not died, but is now used for the US military. It's no longer a civilian system. But in tomorrow's lecture, you will see that this is again coming back in a different avatar. So here are some examples of the mobile satellite service ground terminals. So you can have vehicle mounted terminals like this, and you can have reporting terminals like this, which are either handheld, and then you have a satellite phones. As you can see, this is again the electronics part of it, and then you have the lid, and the lid is actually the antenna. So you have to point to the antenna towards the satellite, and then you can have a telephone conversation. So there is something called the MSS Type B system, and this is essentially how it works is that you have about 30 carriers in the S band, and then you have all these devices which can something like more than 2000 sat phones which can talk to the satellite, and the satellite in turn is managed, okay, and the hub station can then connect you to a local exchange, or it can directly out the voice and data as required by the consumer, right? So this is something that has been developed in India, but this is typical of a mobile satellite service voice terminal, a sat phone. So this particular type D is this model. All that you have to do, as you see in the picture, is stop and communicate with clear line of sight. So essentially he has opened the satellite receiver, pointed it to the satellite, and then he is holding a conversation. And this is primarily been made for disaster relief operations, and that's why it's called MSS Type D. And in future, these additions will be made in terms of encryption as well as in terms of adding data transmission apart from the voice. Now, this again is a very interesting example of marine application. So, in this particular case, the issue was that there are a lot of fishing vessels, and these fishing vessels tend to stray away from the national waters and stray into the national waters of other countries, which results in their being arrested and so forth. So what has been done is that they have been given a small device which is called the MSS reporting terminal, and that device has got a GPS in it, and it transmits its position regularly. This transmitted position is then received by the satellite and sent to a hub station, which then sends it via internet to the controlling station for these ships, in this case the Coast Guard. And so you can see over here how the ships are being tracked, okay, and each ship position is also tagged with the time and the location, right? So therefore you can know the where the fishing vessel has been at any time of the day. The biggest part is the moment they are straying into a wrong area, immediately they can be alerted by the Coast Guard and told to come back. This is something which is also called geofencing, right? So literally you have a fence and electronic fence over here. So the moment the boat crosses the goes near the fence, immediately they are warned to back off. So this is again an application of a mobile satellite service. Then this is the aeromobile, which is something very big today. Now, for example, service providers like Emirates, for example, and a lot of other airlines now offer you internet services on board. In fact, you can use your own mobile on board to receive internet, receive messages, and even talk. How does it happen? Well, you have the base station which talks to the satellite, and the satellite talks to receivers which are mounted on the aircraft, and therefore any user which is sitting in the aircraft and has his own device can connect to the server on the plane, which connects through the satellite to the base station, and the base station is connected to the internet. So that's how the user on the plane is able to connect to the internet on the ground. So here is how the onboard systems look like. So here what you see is that there is a antenna for receiving the signal from the satellite, receiving and transmitting from the satellite, who are sitting with their own devices, and these devices are in a local network with the system on the aircraft, and the signals are being received and transmitted to the satellite to the aeromobile receiving station. Now there are other services I have mentioned to you. Again, I am quoting the INSAT examples. There is the meteorological services. One is the very high resolution radiometric imagery, which is collected by INSAT regularly, and this is transmitted back to the India Meteorological Department Earth Station. And then you have the meteorological data dissemination. That is, you have a lot of remote stations, automatic weather stations, which are collecting data on rain, temperature, humidity, wind speed, and these are all automatically connected, and periodically these are transmitted back to the satellite, and they are received at the India Meteorological Department office, where they are analyzed, and then are again put back through the satellite to various end users in the country. Then there is something called a cyclone warning and dissemination system which has been developed. We will talk about this a little later. Satellite aided rescue, again I mentioned this, we'll talk about it. Then standard time and frequency dissemination service is also important. Well, we keep forgetting this, that a lot of the stuff that we do is very much time dependent. It is time stacked. Now, if you do not have a standard tag which everybody links to, you get into problem, right? So therefore, a standard time and frequency dissemination service is one of the important other services of any fixed satellite. So here now is a search and rescue scenario. In a search and rescue scenario, what happens is there are two satellites which are in the low Earth orbit. One is called the COSPAS and the other is called the SARSAT. One is Russian and the other is Canadian. What the satellites do is that they keep looking for any signal coming in a particular band, which is in the L band, which is meant to be a distress signal band, right? So, and at the same time, all these kind of devices like ships, like boats, like planes, like individual people are all they are equipped with what we call as the ELT. Okay, that's the emergency transmitter, right? Emergency local transmitter, and so forth. And all these, the moment a vehicle or a person gets into a problem, these transponders are immediately automatically energized. So immediately they start sending a signal that there is an emergency to a person or a vehicle and at such and such location, right? The difficulty that is there is that since these are low Earth orbit satellites, it's not necessary that they will be always above such a situation. After all, there are just two satellites, right? So what INSAT does is it also provides the same receiver, okay, and then once it receives a signal, because it doesn't know when it has happened, but it says that I have got a signal of a ELT, and it immediately transmits it back to the search and rescue station. The search and rescue station then immediately alerts the rescue forces that that we have found a source of problem and this has to be attended to. Then the COSPAS SARSAT also they start looking for the, and then the rest of the things follow. Okay, so this is again typical emergency situation where you see you have a VSAT which is mounted on the van, and then the interesting is the VSAT gets connected to something called a small wireless and local loop telephone system. So these telephones are portable, so you can take these telephones and move around in the disaster area and keep reporting back, and they reporting back whatever they report back is fed to the VSAT to the central control system. Okay, so here again are certain other applications. So here is the remote transmitting station. Here is the what I mentioned to you about automatic data collection buoy, which contains the electronics part of it, and here is the transmission part of it. And then you have the cyclone warning dissemination system. A little bit about this. And so here is where you have the antenna. So whenever there is a cyclone warning, the antenna automatically receives that warning, and it actually actuates a messaging service as well as it sounds a siren. And just to ensure that the signal has been properly received, there is this transmitting device which again transmits back to the satellite, which says that this particular installation has received the warning signal. In summary, what we have seen here is that we have looked at different types of satellite services, We have looked at the various frequencies which are allotted for these services. Then we have a little bit understood about the kind of uh, so, private organizations as well as government organizations who are uh, operating these services. And then we have seen examples of fixed satellite service and mobile satellite service and other satellite service. So that is the end of the presentation. I am sorry I exceeded my time, but I am ready to take some questions.